up here, and I'm going to turn the floor over to Will.
Okay, so my name is Lily Ritchie, and as some of you may know, I'm a fourth-year math major here at UCSB. And this is my mathematical approach to environmental science. So before we get any further, can anyone tell me what theoretical math is? Anybody have an idea? Yeah?
I can give you the correct answer, but logic, using logic to solve problems.
Yeah, that's pretty close, actually. This is a quote I pulled from MIT's website. It's pretty exact, but it makes sense. It says, it's the study of basic concepts and structures that underlie mathematics. Its purpose is to search for a deeper understanding and an expanded knowledge of mathematics itself. So it's basically saying that we're trying to figure out what's going on behind the scenes of math. A peer of mine in the math department explained it as trying to prove why math works. I think that's a pretty good statement. So does anybody know what a proof is? Yeah?
When you're talking about math, it's like when you use like simple equations and then you end up like adding them up or manipulating them to prove that a certain like theorem is correct.
Yeah, yep, definitely. Michael Hutchings of UC Berkeley said it's an argument which convinces other people that something is true. Notice that this will apply to any discipline, but I pulled it from a math PDF. I say that a proof starts with assumptions and a goal. The assumptions and the goal are usually stated in the beginning, so you're like, we're going to assume this and we're going to try and end up here. There's two very important people involved. There's the proof writer, he's the one writing down each little step. And the proof reader is the one reading the proof and making sure that he or she agrees with each step. And this is a little diagram I made. So we might start with a few assumptions, then together we get a few implications from that, and then we could argue that those implications lead us to this conclusion. So then the reader is going to make sure that he or she agrees of each of these arrows. You know, I want to make sure that I agree that this assumption leads to these implications, and that those implications lead to this conclusion. So this is my mission. I just want to point out how important it is to be skeptical about anything that you read. We're going to act like little mathematicians and unpack some work here. Furthermore, I just want to convey that in the future there might be someone there to question your work. And if you think like a mathematician, it can help you prepare for when that happens. So in one of our workshops, our classmate Matab pointed out that this would probably be a really good example to use. Turns out it really was. It might be familiar to you, it's the Keeling curve. So Dr. Keeling started taking measurements of our CO2 in the atmosphere in 1958. The data starts here, and it goes up to February 27th, 2016. That was like about a week ago. So what are some conclusions that can be drawn from this graph? Or even if you've seen them before and been told that they are implications. Like, can anybody give me an implication of this graph? Yeah?
It's increasing.
It's increasing, definitely. Anybody else?
We're gonna die.
We're gonna die. Maybe. With a little bit of argument, we might be able to get there.
Seasonal variations.
Yeah, definitely. So now, this is the same Keeling curve, except now we're viewing data over 800,000 years. So you can see there's this nice little trend going along, and 1700 is about right here when we began industrializing, and then the data just shoots off the graph. So this is a lot more striking, and it's important to see that if we just manipulate one variable, here it's time, the data changes a lot. So are there any questions? You guys are readers, so make sure you're questioning what I'm doing, and if you have any questions, feel free to speak up. So, end of the line, we all watched it together in class earlier in the quarter. If you go to their website and click on About the Film, you'll find this little excerpt. It says scientists predict that if we continue fishing as we are now, we will see the end of most seafood by 2048. So now we're going to watch a little clip from End of the Line, just to spark our memories about that.
Julian, can you turn the light off? Thanks.
And if the current trends continue, the stocks of fish which we now eat will have collapsed by the middle of the century.
What we noticed was the curves, they were separating, the high and low diversity curves, but they were both dropping.
All the fish and invertebrates that we eat, that supply us with seafood, we found that by 2003, about 1/3 of them were in what we call a collapsed state. Over the last 50 years, there was a very, very clear trend of year after year after year, more of these species were in that collapsed category.
They started very high, they kept dropping and dropping and dropping and dropping. And if you take those curves and you say, well, they're dropping, when are they going to hit zero? When are they going to drop down to the point where the fisheries that we're used to are no longer going to be possible? And those curves drop down and they hit zero about 2048.
This is not some horror scenario, it's a real possibility, and it's not rocket science, because if we're depleting one species after another, it's a finite resource. There will be a point in the future where we will run out if we don't change the way we treat this global resource.
Thank you. Okay, so the assumptions made by Boris Worm in that little clip are, he says all the fish and invertebrates that we eat, we found that by 2003, about 1/3 of them were in what we call a collapsed state.
So speaking here in Tokyo.
I got it.
How are you getting on? Well.
So then he also says this is a finite resource and we eventually will run out if we don't change the way we treat this global resource. So the first one's saying that we got ourselves to a certain point by 2003, and the second one's saying that we're still going down that same path. This graph shows that path. The dotted lines start about 2003. This leads us to that 2048 projection. And this is what that Professor Steve Palumbi was talking about when he kept doing this with his hands. Just that the graphs, you know, they continue them down, and that's how they got to 2048. So now let's step inside the math silo and question their argument. This is Boris Worm. He's the main author of an article in Science magazine titled Impacts of Biodiversity Loss on Ocean Ecosystem Services. It was published in 2003. This article laid the foundation for End of the Line, and many other things, actually. So he keeps using this term collapsed state. What does that mean to you?
Like you can't recover from the state it's in?
Yeah, definitely. Anybody else want an answer? Michael?
It refers to a fishery that basically is, there's not enough fish out there to really support a fishery.
Yeah.
The population isn't large enough to successfully find one another and reproduce.
Yeah. All those are excellent answers. I found this term when I watched the film a little bit striking because it was kind of, they made their own term and I wanted to unpack it. So I went to that Science magazine article and found how they defined it. In 2003, they wrote, globally, the rate of fisheries collapses, defined here as catches dropping below 10% of the recorded maximum, has been accelerating over time, with 29% of currently fished species considered collapsed in 2003. So the red font is how they're defining the collapsed state. And that 29% is where Boris Worm said that about 1/3 of them were in that state. So I thought what was interesting, and as Michael pointed out, that they use the term fisheries collapses. They're not necessarily talking about the species, but the industry that's after that species, not being able to recuperate. And then another interesting thing that they define is the recorded maximum, and that's just the biggest catch that they have on record since 1950. So if their catches drop below 10% of that, then the species is considered in a collapsed state, according to this article. So now that we've unpacked their definition, let's see how it's being used. This is Charles Clover. He's also an End of the Line. He wrote the book End of the Line that the movie was eventually adapted from. And he also wrote an article for The Telegraph that came out the same week as Boris Worm's Science Magazine article. So the article is titled, "All Seafood Will Run Out in 2050, Say Scientists." And this is that typical shock value that everyone loves to use to get the public's attention. And it is an internet article, so he's trying to get people to click on it. But what I found is that just the third sentence down says, by 2048, to be exact, catches of all presently fished seafoods will have declined on average by more than 90% since 1950. So I would argue that this is an excellent use of his source because he's using that shock value that's more or less important, especially in environmental science, but his sources back up what he's saying. And he's definitely using the term catches rather than species or population, which is important. So are there any questions at this point? Okay. Now let's turn our attention to Ray Hilborn. He was also featured in End of the Line, but pretty briefly. He's skeptical of Boris Worm's work, as am I, and he wrote a book called Overfishing, which criticized the data and the conclusions that Boris Worm worked with. So, Joseph E. Taylor III wrote in a book review, he summarized Ray Hilborn's argument and said that the problem is that global trends do not necessarily capture local events. So what Ray Hilborn has done is taken Boris Worm's argument and noticed that it's on a global scale. So when he shrunk the radius down to a local scale, he found that the data doesn't argue the same thing. So Ray Hilborn is shrinking the geographic radius of the data, and the conclusions change, and it's the same thing as when we changed the time on the healing curve, and the data changed a little bit. So this is important because he's using our assumption as his conclusion. So our assumption is that that 2003 article checks out, and we unpacked it a little bit and see how that they got to that 2048 projection. So then he took that 2003 article and said, what did you base this off of, and how did you end up there? So what do you guys think about the 2048 projection? You think it's valid?
I think that really depends on if people change their behavior or not. If it's under the assumption that fishing remains at the current levels, then probably.
Yeah.
Well, I'm going to guess from the second guy's argument, basically the 2048 projection is valid to a point, but it also doesn't reflect extreme overfishing in some places and good fishing practices in others.
Exactly. That's exactly what Ray Hilborn found, actually. Does anybody else have a comment?
So
Yeah.
is there like a best estimate on how long fish could last after 2048?
So Boris Worm's argument is basically, like she said, that if we don't change our practices, that's where we're going to get to. So even he says that if we just kind of wake up and realize what's going on, that it'll change and potentially be sustainable.
Got a question.
Yes.
I mean, to touch on that, what you said was actually pretty interesting. Waking up, I feel as though as mankind, like we never really, we kind of have our heads in the sand until something bad happens, and then that's where, you know, we kind of change our ways, you know, like a New Year's resolution kind of thing, just for a bit, just for like a short period of time. So I feel as though like within, I would say, 2040 maybe, we would start being like, oh wait, like we don't have enough fish, so we'll start, you know, kind of mitigating that, but I don't think that'll last very long, so it's going to collapse.
Yeah.
Did you notice that these scientists
are arguing like an inevitable collapse, or if it's just they're arguing on when the collapse will be, like if it's inevitable or if it's arguing if it's going to happen or not.
Are you talking about Boris Worm and his Science Magazine article on the end of the line part?
Yeah, and the ones who argued it, did you get an idea that they were pretty much predicting a collapse, like all collectively? They're just arguing on the date, or if it's arguing that it'll happen or not?
Yeah, so Ray Hilborn's arguing whether or not, he's not arguing the date, he's arguing whether or not it'll happen.
Okay.
So also, if you read the Science Magazine article, it says a few times that we have to continue down the same path, just as those assumptions were.
Okay.
So the second one said that we have to continue down the same path to get there. And they're kind of unclear about that in the 2028, or the end of the line film. Are there any more questions or comments? So earlier in the quarter, we read this article called Historical Overfishing and the Recent Collapse of Coastal Ecosystems. We refer to it as the Jackson article because he's the main author on it. It just talks about historical overfishing, and one of the main arguments is that we have to look back for 10,000 years to look at the real impact of humans, and that it's important to incorporate history into ecology so that we can get a better understanding of what's really happening. So, in the following class period, Professor Martin pointed out a little piece of irony that none of the 19 authors on the article are actually historians. Most of them are in ecology or biology. So they're all in the same silo. So do you think that the article is discredited by the lack of historians in the list of the authors? Yeah.
I don't think it's discredited, but I think it lacks a deeper understanding, maybe.
I would agree with that. Does anybody else have a comment? Yeah?
I don't think it's discredited. I mean, sure, there might not be historians that are like looking into maybe like the social aspects of this or like first person narratives from back in time, but I guess if they can look and see how something was different then to how something is different now, then I guess that's history, so you get a basic understanding of it.
I would say that I would agree with everyone else that it's not really discredited, but I think my reason for that is you don't want to make it an ad hominem logical fallacy and say that just because it's written by a bunch of biologists and not a historian, it's not correct. That's not good logic. But I will say that the experience of those biologists and their ability to sift through information and what could be true versus true, quote in danger quotes, could compromise the dependability of the source.
Yeah, I agree with that, and my thoughts here are that we just stepped inside that math silo, especially most of you are environmental science students. So I wanted to point out that it's possible to leave your little perspective and reasoning of thinking, but it might be difficult to do so if everyone on the team is of the same discipline. So this is the third question I have. It's a little bit deep, but would anybody like to answer it? Does anybody have an idea? Gia?
Yeah, just like from my research too, it's just like a lot of kind of like a clump of everyone's opinions of like the ocean because it's such a vast secret. Like we just think it's like we said in the previous class, it's just like we just think it's like something just like right there. But there's so much out there. There's more ocean than land. So there's just more things to deal with. And there's just a lot more perspectives, a lot more studies. It's a lot.
Mm-hmm.
Can I ask a question?
Yes, absolutely.
Are you referring to the history of oceans that we study in this class or the history of oceans in general?
Whatever it means to you. You want to answer it now?
Oh, sure. Trying not to jump in too much, but
No, it's fine.
basically to me, I mean, there's two different ones. History of ocean, as we study in this class, history of oceans is history of man's interactions with the oceans overall. But the oceans themselves also have a much deeper history that goes into the biological and geological and other natural histories as well.
I definitely agree with that statement. So, Professor Meyer has posed this question to us quite a few times over the quarter, arguably every lecture. When I first came into the class, I thought it might be a pretty easy question to answer, you know, like, boom, here's the history, let's study it. But then just really quickly, we were exposed to all these little obstacles that you hit, and it's really difficult to answer the question. So, what I hope what we would take away from this is that history has been made and written, just like each assumption that we've encountered in our little proofs. So there seems to be this never-ending chain. Any assumption that you decide is true and base your work off of can be treated as a conclusion. You know, you can question what is this based off of, and what is that based off of? And it just keeps going back and back. So any piece of data or thing that we consider fact can be questioned. History is written, and so are proofs. And in math, we place equal importance on the writer and the reader. So the reader is a key part in the validation of every conclusion. And in history or any different discipline, the reader should be seen as equally as important. We're all readers in life, and we have to make sure that we agree with what somebody says is an implication of something else. So because of this, I would argue that there are infinitely many histories of the ocean. But as readers, that is your conclusion to question.
Wow. Brilliant. Thank you all for participating. Thank you, Lily. That's fantastic. I hope everybody has a great weekend. Don't forget to turn in your worksheet committees. And out to